A very good afternoon to everyone. I'm Florence Bridget George, currently pursuing my third year in Electronics and Communication Engineering, and it is my pleasure to welcome you all to Daily Beginnings, an initiative by SA Engineering College, created to guide aspiring engineers as they embark on their journey toward higher education and professional excellence. SA Engineering College, named in honor of Srimati Sakuntala Ammal, the matriarch of the institution, was established by the Dharmanaidu Educational and Charitable Trust during the academic year 1998 to 1999. Since its inception, the institution has remained committed to providing quality technical education and shaping skilled, future-ready professionals. Over the years, the college has grown into a distinguished autonomous institution affiliated with Anna University, recognized for excellence in academics, innovation, research, and industry-oriented learning. The institution continues to flourish under visionary leadership. The mission of our management is carried forth by our correspondent, Mr. S. Amarnath Sir, and Secretary, Mr. D. Dasarathan, along with the academic guidance of our respected principal, Dr. S. Ramachandran Sir. Today, as technology continues to evolve at lightning speed, the transition from school to college becomes even more exciting and important. To help students gain insights into emerging technologies, future career opportunities, and essential industry skills, LaunchPad 2026 has been organized. Today's session revolves around the inspiring theme from smart devices to smart worlds, engineering the future through ECE. This theme beautifully reflects how electronics and communication engineering powers the world around us, from the smartphones in our hands to the intelligent systems shaping tomorrow's cities and industries. To guide us through this fascinating domain, we are honored to welcome Mr. Rajesh R. What makes today's session even more special is that Mr. Rajesh is also a proud alumnus of SA Engineering College, making his journey especially inspiring for all of us. Seeing someone who once walked the same campus, sat in the same classrooms, and is now making remarkable contributions on a global stage is truly motivating. He is currently pursuing his PhD in audio signal processing at the University of Illinois, Chicago, USA, where his research focuses on advanced audio technologies, machine learning, and intelligent signal processing. He completed his master's by research at IIT, specializing in music source separation and interference reduction. He also earned his bachelor's degree in electronics and communication degree, securing an impressive university rank. His research contributions span audio signal processing, machine learning, acoustic sensor networks, and interference reduction, with several publications in reputed international conferences and journals. Through his academic excellence, innovative research, and contributions to emerging technologies, he continues to inspire students and researchers to explore the limitless possibilities of engineering and technology. We are delighted to have you with us today, sir. We are confident that your insights and experiences will provide valuable guidance to all aspiring engineers here. Without further delay, I invite Mr. Rajesh R. to address the gathering. Thank you, sir. The platform is now yours.
Thank you so much for the warm welcome. Let me go to the slides. So, hello everyone. So, as she said, like I'm Rajesh, and I have an alumni in SC Engineering College, studied in AC department. Before going forward, like I just wanted you guys to ask that, like, should I talk in Tamil or all comfortable in English? Anyone? Unfortunately, I can't see the chats. Let me go if someone has said something. English, okay. Okay, maybe I switch like this. Yeah. So this session, let's keep it very less technical and more of curiosity. So this session focus on how we could able to engineer the future through the Department of ECE. So this topic revolves around like how and what exactly is ECE and how modern technology has been built with ECE technologies. Okay, so let's start. So let me start with a basic question. So this is the very fundamental slides. Like whenever whoever starts the ECE, they will ask this. So imagine a day without these electronics, how the life would be. So these electronics are the basic ones, say calculator or some digital print boards, something like that. So how it will be? So in today's world, like these electronics are like nearly nothing to us, right? Like because we have calculators in mobiles and like we never use them, like actually except in exams. But anyway, so long back, like these were the electronics which has shaped the world, right? So what that was in dinosaur era, not now. So when like I was studying my BTech, so we had a smartphone, we had like Instagram, Facebook, these kind of social media. So all these smart devices like are the inventions of the recent electronical developments, right? Like so it has like lots of special features which probably and will be you will be learning in 4 years of your engineering. But like this itself is like a kind of era which has been gone, right? Like it's in my era, it's 90s kid. So imagine a day without the AI right now. So before that, like let me ask you guys, like, so what are the AI technologies you guys know? Let it keep it two-way, like we can engage in a way that like we can talk and then we can discuss. So that will be this session will be more interesting and useful. So anyone? So what kind of different AIs you are using in the modern day? You can chat, like I can see. If you are very shy to talk, you can type chat GPT, very good. Next. Yeah, ChatGPT, like all the LLMs, like these are large language models which comprised of ChatGPT, Gemini, so Facebook, Claude, exactly. Uh, any AI which is related to image recognition, something like that, image generation, maybe, or voice assistive listening. We all have in smartphone. Siri, Alexa, and almost all the mobile phone cameras now has AI, right? So that sorry. So that's the new trend now. So we all have this fancy AI stuff which assist us today to do larger and larger works. So I still remember like when I was like doing my BTech, like to do some project. Let's say if we want to build some software or like hardware related things, we have to code from scratch and we have to learn that coding syntaxes, those things and all. But now thanks to all technology that like we can just type the prompt and like AI could do numerous things, right? So how did we progress from a basic calculator to this kind of powerful AI? And like, is this possible without an electronics and communication engineering background is what like we are going to discuss today. So we have all these things, right? Like which you guys named it. So starting from all social media apps, let's say Instagram, Facebook, YouTube, and all the coding platforms and different LLMs, smartphones, earbuds, meta glasses, and Alexa smartwatches, everything. Like you even say the UPI payment, which we do every day. So everything is centered with our discipline, the electronics and communication engineering. But how? This all looks like AI driven, right? Like it looks more of a computer science, like, but how does it related with an electronics and communication engineering? That doubt you might probably have. So to understand that, like we have to see like what exactly is electronics and communication engineering. And I don't want you guys to be make bored with like textbook definitions or something like that. And I want to ask you guys the same, like, what do you guys know about electronics and communication engineering? Like, how do you define it? So what do you guys think electronics and communication is actually? Anyone? It's a simple question. Like you can type whatever you guys want. Like first of all, I'm not a professor here, and I'm just a researcher. So you can be like freely. You can talk whatever you want to me. To me, yeah. To create devices for communication, exactly hardware and software. Yes. So to engineer these hardwares and softwares, to engineer the way we communicate, right? In ECE, we have two opportunity like software and hardware. Exactly. So yeah. So to understand that, like I have a picture here. So EC is something related with these four cycles, fundamental cycles. The first thing is with sensing. So any process or any electronic machine will sense and then like think, then communicate, and then act, and then will give us the response, right? So this is how our recent smart systems work. So as you guys said, like ChatGPT. So how does ChatGPT sense our speech? Like in every recent AI, the first step is to send something, right? Like if we are talking with the voiceover mode, then it has to decode our speech signal. Or else, like if we are willing to type like a chat GPT for the case, like it has to understand our English language, right? So it is kind of sensing which happens within the system. So right after the sensing, then it has to process something, right? So that is what like I have written here. If you have seen that, like it has to process the data, say what it is actually asking or what it actually represents. Then it has to communicate with other system if it wants to. For example, let's say you want to generate an image in ChatGPT. ChatGPT itself is not an image generative algorithm, if you guys are not aware of it. So ChatGPT is a text transformer which just does all the text operations. For image, they use different types of generative networks. So ideally, it is communicating with one network to the other. And then like it has to act, and then like again it goes to sense, like, and again it has to think and communicate. So by seeing this figure, now can you guys redefine what this electronics and communication means? So for example, if you take this smart system, it has everything, right? Like from starting from electronics, say mobile phone is an electronic device, and sensing. For sensing, we need a microphone, or like it has to understand the text input, that itself, like conversion from analog to digital. And it involves lots and lots of all circuits, which is hidden behind our processors. So everything happens in sensing, right? Then thinking is comes where like highly programmable logic stuff, everything. And then communication is what like our title says, right? Electronics and communication. how effectively we communicate between the systems and do all other stuffs. And then we have to repeat this cycle. So electronics and communication is not just limited to mobile phones, AI, and related things. It is mostly covered with almost every things we see in day-to-day life. For example, drones, autonomous cars, smart home, and hospital equipment. So these are the fantastic research which are uh, taking shapes in recent days, and industrial robots, satellites, wearable devices. So let me ask this question. So it will be very interesting. Yeah, I will come to that like in 30 minutes. Like I have, okay, let me tell like what this session is about. I will explain like what exactly is ECE and like a little background about me and what are the skills required to be successful in ECE and what exactly you guys need to be studying and what you guys need to be focusing on this AI era. And so AI should not replace us, right? Like that is the scare which everyone will be having right now. So to mitigate that, and then what are the opportunities after studying EC is what my session is about. So I will go through that in a few minutes. So before that, you guys have seen Indian movie, right? So what do you think about that movie? Like what are the background things which you think might consist of ECE? For example, if you take the Chitti robot, so everyone thinks it is an AI and robotics, right? Like what components must be studied, or like what basics do we need to understand that uh, movie, or like to make such a robot? Chip, exactly. Do you like that movie a lot? Like I personally like because that is awesome. So have you guys so if you guys have to think of each and every technology that has been used in a movie, so everything to make those things, like we need an ACE background. So that's the point, that's the importance of ECE actually is. So A is just an application layer built upon the ECE. So let's go through the next slide. So how everything started, like I don't want to keep the years or like the technologies where we uh, possibly crossed. So just the overview, we have started from electronics devices, right? Basic electronic devices, circuits, basic binary operations. We started from there and moved to chips, VLSI, like a very large scale integrated circuits. And then we just move on to a Nokia mobile. Like if you guys know about the small Nokia mobile, like I don't know whether you guys know that or not, like, but like I remember in my childhood that everyone used to use the small unbreakable Nokia mobile. If you can see that in the uh, slide here, like in point 3. So actually it is unbreakable and that battery will never die for 7 days. And from there we move to smart devices, which we are using now, like smartphones, smart tablets, and watches. And then from 2010 and onwards, like we entered the AI and machine learning era, which shaped the world, right? Like from autonomous cars to human level intelligence, which LLMs does now. So in now, like the AI could do almost every task which we wanted to do, but that's not the full story yet. So that's what like we will be talking now. So before that, let's take a simple example, and let me ask you guys a question, like what makes our phone really smart? If I just say smart devices, what actually is smart? Uh, can you guys type it? What do you mean by a smart mobile? Like why this mobile is smart? Why do we call that is a smart? Android, iPhone, whatever it is. Immediate response. Okay, that's good. Uh, So think in this way, it performs many operations. So yeah, exactly. It performs many operations which we wanted to do, right? Like it can understand us seamlessly. It can do many parallel things at the same time. And it, yeah, you can ask. Yeah. Someone raised the hand, right? You can just unmute and stop me whenever you want. So that's fine. It gives what we need. So exactly. So now almost we can do all photo editing or like all speech editing, uh, and the games which the games are like it has like very great graphics, and what else like the internet connectivity is very fast, and social media apps itself, like if you take the Instagram or Facebook, so almost all the operation which happens there has an AI and like a AI behind it. So yeah, so that's what, right? Like almost if you take the cameras, if you take the microphones, if you take the GPU, Bluetooth, Wi-Fi, processor, battery, display, each and every component in a mobile phone is a part of ECE. So we call it smart because it can able to process and understand us much better actually. So whether it be a cellular connection or like sensor networks which is embedded in it, data security and operating systems, say Android, iPhone, and like all other and operating systems, and whatever the storage devices, right? Nowadays, like our gallery can understand who is who. Like it can understand the face, and it can even like create memories. It can create videos of us, and it can do lots of other things, right? So everything is a part of ECE actually. And I will go through a basic overview of how ChatGPT works actually. So let's say like we are operating in a voice mode, or just we are typing and asking the question. So everyone might be thinking this AI stuff is just computer science discipline, or it's something different other than electronics and communication engineering, right? So my point is that like it is actually not. So I wanted to show you like how EC is hidden behind those ChatGPT system itself. So if you guys see here, so the conversion from voice capturing using the microphone, the first fundamental step itself is a part of electronic component, right? And then like the signal processing stuff, so which is the major fundamental first step and major discipline in the AC itself, signal processing. And I work in signal processing actually. So all the understanding of signals and how to convert so that like the AI systems can process seamlessly happens in the signal processing section. And then like a highly trained model will understands the signal processed signal, and then it gives us the response. So if you see here, almost every component in a ChatGPT has a signal processing and electronics and communication engineering background. Only this part, then artificial intelligence has uh, something different, right? So probably that is also not different. Like I will I will in the future I will say that like that will be also a part of ECE and mathematics actually. So we moved from smart devices like smart cars, smartphones, smart watches to a smart world. If you see like almost everything which we see today has some AI inbuilt it, electronics, smart electronics it has. So ECE is actually inevitable. That's what like my point is. So to study this, to understand this, and to engineer these things, we so we need more than AI actually. So AI is just an application. So ECE is the fundamental root. So if we understand that, then we can do anything we want. Yeah. So this is the one good picture which is generated by ChatGPT itself. Like it's very cool. If you can see that, see here in the application layer, you can see all the applications which or which you have used so far. You guys already said ChatGPT, Claude, Gemini, Copilot. If you guys know Perplexity, and much more AIs, right? And these are called the large language models and the AI systems, which is developed by OpenAI, Anthropic, Google, Meta, which you guys all are aware of right now. And you guys all know about the cloud infrastructure and data centers, where it is stored and how it is got processed and all. But the ultimate background, or like the backbone of all these things, are semiconductors, signal processing, communication networks, embedding systems and power system, and RF and wireless transferring and control system. So what all these things? So all these things are called the electronics and communication engineering, which you guys will be studying. So all these things are the core fundamental important to achieve those application layer ideally. So such important domain is ECE. So the very most important point I want to make is like AI is the new common, but core discipline stays taught. So can anyone understand that statement? So what I'm trying to say is AI is the new common. So AI is like becoming like an electricity. It's like necessary to everyone. And AI need to be learned by every discipline. For example, mechanical engineering, civil engineering, computer science, and it has its own discipline too. So how come like this AI and this core disciplines are different? So there are lots of differences, but let's think about in electronics and communication engineering perspective, how and AI are differed. Does anyone needs to take a guess? You can type it or you can just unmute it and you can talk. I'm not a teacher or I'm not a professor, right? So you can talk anything, like you can give answers, you can even troll me, whatever. Yeah, just like you can type it or make the session engaging. That way it will be very good, right? So what do you think? Like what will be the fundamental difference between AI and EC itself? What do you guys think? Like how it might be different from? So as I said, like EC is the foundational floor, and then AI is built on top of it, right? So any guesses? No. Okay. So so the point like I wanted to tell, which you guys all need to be remembered, is AI is something different, which everyone needs to know by now. But without core disciplines, AI is nothing. The core disciplines which I am meaning is like not just electronics and communication engineering. It is with respect to all the engineering discipline. Let it be biomedical engineering or mechanical engineering, civil engineering, and whatever it be. So A is the common thing, which is like an alphabet which everyone needs to know, and the core discipline is the most important thing. So AI and the EC makes the future of today and probably tomorrow also. Yeah. So now let me talk about me. So it's like a shameless self promotion. So as everyone know that like I have studied in SC Engineering College. Like I have did my bachelor's here. So in 2018. So from 2014 to 2018, I have studied EC in SC Engineering College. Then I have worked for a company in IIT Madras for almost 2 years, I guess. So as a data scientist, then I realized that uh, working like this IT jobs or data scientist, software development, or some data scientist is not my role, because I'm much interested in learning and researching stuff. So then I just gave GATE exam, and then I moved to IIT Mandi in 2024. Like I have passed out in 2024 and I have joined in 2021. So I have completed my MS by research actually. And then right now I have moved to Chicago in 2024, and I am studying my PhD in audio signal processing. So right now I am in listening technology lab, which is a part of University of Illinois Chicago, and this is my campus. Backside is the Chicago skyline. Like this greenery part is my campus actually. So what we do actually, so what me and my research group does is like various electronics and communication engineering research ideally. So it starts from assistive listening systems and immersive technologies and sensory augmentation and hearing aids. So before going, like these terms may be like too much for you guys as you guys just completed your 12th standard. But by seeing these pictures, do you guys like uh, know what it is? Like augmented reality and assistive listening systems and hearing aids. Uh, First question: do you guys know what hearing aid is? Obviously, right? Hearing aid is the an assistive system which is like used to enhance the sound for the people who have hearing loss, right? So let me tell you some facts that like hearing aid till today can't distinguish where the sound come from. So for example, like let's say I have a hearing loss, and if I close my eyes and there is a user just before me and a user behind me, if we close your eyes, we can able to distinguish who is before us and who is behind us, right? How can we able to do that? If we close our eyes and if someone are talking, we know direction, right? Like from which direction people are talking from, or like what actually they are talking from. We can able to do everything without an hearing loss. But people who has hearing loss, they are having some kind of electronic device which do some speech processing to enhance those speech for them, to make it louder or to do all other AI stuff. But still, like they can't able to understand or differentiate where the sound comes from, like which direction the sounds come from. So that is a kind of trouble, right? Like imagine us like without knowing like where the sound come from. So people are still living like that. So to develop such systems which should match the human ear performance, we definitely need an electronics and communication engineering background and do lots and lots of research on that. For example, this specific researches are called as audio signal processing. That's where like me and my research groups are working on. And right now, like you guys are listening to my session, and there will be lots of other noise too, right? Like in your homes or like wherever you guys are attending, there will be lots and lots of other noise. For me, like there is an fan noise or like background mobile or like traffic signal noise, right? But still we could able to you guys all could listen to me seamlessly. How does it happen? Like for our human ear, like it's actually listening to multiple sounds at a time, but it is focusing on to a specific speaker, right? For example, you guys are focusing on me, so that like all other sounds are going in a background. But if you're not listening to me and if you guys are doing something else, then that would be your focus, and I will be in the background, right? Our human brain can able to do this seamlessly, but can a machine do this? So this problem is called a source separation problem, where like multiple sounds are mixed and we want to like extract different sounds from each source of interest. So this kind of problem is what like me and my research group are working on. So you guys can see like what we are working on broadly in this link, but probably I will be sharing the QR link. Contact, you can see there like in detail. So any doubts, like any questions you guys want to ask, like what type of research which you guys don't understand, like what I am actually doing. I can switch to Tamil if you guys are like if you guys are not getting it too much. Yeah. So any questions now, like about my research and research field, what we do, and how it's related to electronics and communication engineering? Obviously, it is ECE because I work on signal processing. So any questions? You can type like if you guys have, if you guys are shy or something like that. Or else you can ask later too. Like I will share my contact. Like you can anyway ask. So why I chose research? So this question might be familiar, or like you guys might be wondering like what, why actually I need to do research. The first question is like I like curiosity and to ask questions. Uh, so which means like I like to do something which is actually not present in day to day life. For example, if we go for some work, right, software development or something else, it will be like kind of repetitive in nature for after few years. But research is something new, right? Like we have to keep pushing the boundary. We have to keep inventing something. So initially I thought that like research is something like which undergrads like BE, BTech guys will do. But then I understand like even a PhD, even in right now me, like I can't do multiple independent research. Then like we have to establish our own lab and do lots of research of our interest. So I like to study very much, and then like I have to I like the signal processing and math behind that very much. So that attracted me to do research ideally. So this picture I have included because you guys can see there is a room we are sitting in, right? Like some kind of mic is there and some kind of panels are there. So and do any guys know what kind of room is this? Any guesses? You guys should probably know. Can we? Definitely not. So there is no. So there was a question from Dwakesh, like he is asking that like whether master degrees are necessary after BTech. Definitely not. It is my interest to do research. That's why I was like continuing to MS and PhD and like postdoc probably. But like it's not mandatory. Yeah, soundproof room. That's correct. Exactly. So this is an acoustic chamber. Like those recordings all happens. So whatever the sounds we make will never be traveled outside of this room. So this is in our lab, like where we do all kinds of recordings. So here is my QR code for my website. Like there, like I have put all my research papers, all my projects, and my contact. You can contact me. You can text me in email or GitHub or like Instagram, modern day Instagram. Okay. So yeah, let me pause for some time. You can take photo of this, or else you can type the link above, or else you can just type Rajesh RUIC, like the Google pops up me. And not only now, like even in future, if you guys have any doubts regarding the research or regarding future studies, higher studies, you can ask me here. We have 15 more minutes, so I will just go through most important things which you guys have been asking for. So what skills does future engineers need? So to be very specific, what does an EC engineer expecting to graduate in next 4 years? What skills they do need, right? In this AI generation. The first thing, which may sound stupid for you guys, but that's the mandatory thing, is like strong foundations. So you guys should need very solid understandings of mathematics, physics, and problem solving skills. So these are the foundation where every engineer should know, irrespective of the discipline. So physics is not something which we have studied in 12th standard, right? Like physics, I mean here is the physics of the discipline. For example, for electronics and communication, electrical circuit devices are the physics I'm referring here. And the problem solving skills is the most important, equally important, like mathematics and physics. And then like the one more most fundamental in recent days is the AI skill. So you guys need to know programming, not the syntax, not the programming language. So I'm not telling that like you guys should know Java, Python, C++, but you guys need to know the logic, how to write a program, how to understand, how to decode, and how to compile those things. And obviously, the machine learning, deep learning things, And more equally, you guys need to know how to use this coding AI assistant. For example, ChatGPT, Claude, Codex, GitHub Copilot, how to use that to do your task. So that is as equally as important like you are learning the machine learning stuff. Then comes the electronics core, like all the devices, circuits, electrical circuits, electronical circuits, digital and analog designs, VLSI, embedded, and much more. Every course you do in your engineering, right? Not everyone likes all the courses, but there will be some kind of attraction towards some courses, right? Like master them. Read logically, you guys need to know each and everything in that, like understand how it applied in practically. So those kind of electronics domain core is actually as important as strong foundation like mathematics and AI. So these things are lies in one side, and the most important thing which I feel that skill that future engineers should have is the curiosity to ask questions. Not ask question to a teacher or to someone whom you know. To it, the curiosity by I mean is the asking ability to ask question to yourself. So why are you learning this? For example, if someone says that like learn mathematics or learn linear algebra, if you guys all know what matrix are, right? Like if someone still tell you that like learn mathematics, that is the foundation, you guys should immediately think why you need to learn. Then there will be some answers why, what, and how. So then there will be like direct connection to all the related things which we will be doing. So it may be sound rough in bit dry when you take the core electronic courses, right? Like for example circuits, or if you're taking engineering mathematics 1 or 2. But you should not lose interest, or you should actually ask the right questions, like why are we learning this. Then you will be then you will be understanding the most important stuffs, like which many will never understand ideally. So everything has like beautiful connection within all these subjects, and which will make us to think beyond what people are like thinking now. So you guys will be the future after 4 years, that you guys will be building the new ChatGPT or like new some AI which we can never imagine in the 4 years. So what's after ECE? That's also the most important thing which you will be asking, right? Like whether research is the only option, or like is higher studies is mandatory for ECE in India. So nothing like that. So there are multiple options. For example, software systems you can go to, like someone said, right? Like software and hardware. So you can either go to software and embedded systems, a machine learning, communication technology, semiconductor, consumer electronics, industry 4.0, which means like smart manufacturing. One second, like you can type if you have any questions around like. Sorry. So you have enormous opportunities after ECE. So I'm not actually biased towards ECE just because I have studied ECE, but I could able to see the scope of ECE very well than the traditional computer science and AI disciplines. So people think that like AI is the new era, right? Like then everyone will run behind AI and data science and computer science discipline, but they will completely disregard this core discipline advantages. Now those things are learned by every discipline. The only these core disciplines are stand out behind them is like we know the core. So which means we can build new systems which all the top people like Meta, Facebook, and who else, Microsoft, Apple are looking for. So people who do computer science are actually not most preferred than they see in those disciplines actually. So there was one question: what's the spark and idea to start and this kind of research, and how this is related to ECE? So so right now you guys may not know like how to think, or what ideally like how this kind of idea pops up, right? That's why I told the most important point, have curiosity. So whenever someone says something to you, like in the class or something, always ask why. For example, like if you wanted to learn something or in the class, like always ask why should I learn, in how way it is connected to things which they are saying. So then you will understand the path, right? Actually, so okay, this is connected to this. If I learn this, then you can achieve this. So if you, the moment you learn new things, right, like something other, like some shortcut or some new ideas will pop up immediately. So it happens only when you understand the systems, or only when you understand the core research or like core discipline. For example, EC subjects or the mathematics, if you understand that very well, then you can easily connect and you can easily develop you will easily come up with lots and lots of ideas or research, or even for works, right? Like you can do wonders, ideally. So higher studies is the most easiest option also. Like you can do master's, PhD, postdoc, whatever it is. You can start your own companies. If you come up with an own product idea, which no one has done, then like, yeah, obviously that. And many people might be very patriotic. So you can like contribute much to aerospace and defense technologies and IoTs, robotics and automations. It's endless possibilities. So EC has like lots of future even after few years. So I need to quickly say my own quote that like maybe this might not be universally accepted, but like what I think is math is the key to everything. So for me, if I just need to give you guys some advice, stick on to the math. Rest everything follows it. If you understand math very good, then like everything will be very easy. You can do wonders actually in engineering. So before that, so we have come to the end. So I just want to give you a simple task actually, so that you guys will be confused, right? Like how to learn those mathematics. I have been keep on telling that ask why whenever you learn something. So I just give some one example. I just want to talk about this, and then we will end it up. So can you guys tell me what's the rank of the matrices which we studied in 12th standard, A, B, and C? Can it doable? Like in probably we have only 5 minutes. Can we do this in 1 minute? Maybe before solving, can you guys tell me this answer? Can we solve, can we compute rank of this matrix A, B, and C in 1 minute? Do you guys remember? First 3 cross 3, okay. What is the rank of the matrix? Rank of the matrix we have studied in 12th standard, right? So you guys have, can you guys tell me? We have done this, right? Take this row 2 is changed to 2 multiplied by row 1, row echelon form, then number of non-zero elements in a row. Do you guys remember? Yeah, B is 5 cross 5. No, I'm not asking the dimension actually. So it's 3 cross 3, it's 5 cross 5, it's 4 cross 4. I know that. I'm asking the rank. Do you guys remember the row echelon form? Something like this. So first row, first element should be 1, the next is 0, the next 2 should be 0, 0, the next will be 0, 0, 0. Then we will count number of non-zero elements in a row. So for example, C has 1, 2, 3, 4. So rank of the matrix here is 4. Yes, right? Rank 1, very good. So you guys have computed rank 1. I don't know how. So so this is what row echelon and Joss Gordon method. Yeah, exactly. So this is what we have learned in 12th standard, right? So now we have reached to a stage where we are studying engineering and we should have a curiosity. So the moment if someone asks you to calculate rank for A, B, and C, you should not use those row echelon form and whatever the steps those mathematics teachers thought of. The first question you guys need to answer is what exactly a rank is, not compute wise. So what rank physically means, what it signifies, what actually a rank is. Then you will realize that these all three matrix can be solved within seconds. For example, if someone shows me this right now, I can say the rank of A is 1 by just looking at the matrix. No paper, no pen, nothing. I can able to say that rank of the matrix of A is 1 B is 5, and C is 4. Do you guys know how did I do that? It is because like I I asked the question what actually rank is, and I understood what is the rank. Then I have just seen. So if we don't understand, then we will be doing for the sake of marks that we will be just solving pages of mathematics and do something, and which will eventually we will forget in the next semester, and we can't do anything with that, right? So this is the difference between traditional mark-based course approach and curiosity based approach is what like I'm differentiating. So for example, like this rank. So rank is ideally number of independent rows in an matrix actually. So independent means like if you see 1, 2, and 3, if I just multiply it by 2, right? Like 2, 4, 6. Actually, these two are same, just 2 is multiplied here. These are same, just 1 by 2 is multiplied here. So ideally, these 3 are only one equation, just multiplication happened in this row, right? So ideally, that is the rank. So I can say this is 1. But if you see here, nothing can be multiplied or subtracted, or I can't do anything to achieve this because it is diagonal. So I can count 1, 2, 3, 4, 5. I have 5 different equations, so rank is 5. So here it's the same, 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4. The rank is 4. So do you guys now understand like what I'm trying to say? We all have studied what is rank, and we all know how to do that. We will all get full marks, 100 on 100. But we never understood what is a rank. We just know to do in a paper, pen and paper. So the point I'm trying to raise is to be successful in engineering, to do great research, or to understand engineering well, have curiosity to ask question why. For example, what exactly is rank? What physical meaning it has? So now you guys have, you are very blessed that like you guys have lots and lots of resources available. So even ChatGPT can teach you enormous things. YouTube, anything like internet has lots and lots of stuff. So you like we can't blame the internet. Like we can't blame the teacher or someone like anyone. Like now we have access to everything. So the only skill which I think you guys need to have is have curiosity, understand clearly what it is, why it is, why we are doing that. Then ideas flows naturally, and after 4 years, you guys will be like having wonderful uh, future. And I wanted to thank the ChatGPT for generating all the images, like almost all the images which have been used in the slide, and all the best for the future. And before I wrap it up, like I wanted to you guys to ask few questions to me. So let's be quick. So whatever you guys wanted to ask me, yes, you can type it off or type it, or like you can unmute and ask. Any questions? Or else you can even text me and email, or like Instagram if you prefer, like I have shared, right? Like, so yeah, if you can ask now or later, like yeah, your wish, like, but I'm available now, like we have few minutes, I think, so you can ask. Any questions? No? Yeah, that's cool. Anyway, like I'm an alumni of S Engineering College itself, so you can treat me as like your colleague. So I'm not like someone who's not reachable. So anytime, any doubts in academics, like even if you don't understand few subject courses, how to learn, and if you are willing to do higher studies and how to join in IITs, or how to give GATE exams, or whatever, anything related to research, academic wise, like you can contact me. What basics should be learned before joining college? Yeah, that's the most important thing. You just to need mathematics, which will be the fundamental for engineering research, right? Just learn calculus very good. this all the mathematics which you guys have studied in 11th and 12th is the most fundamental thing to be start with. So just learn that, then have curiosity. Just ask questions whenever someone is teaching something. Like ask yourself like why you are learning, what you are learning, understand its physical meaning. Then right, yeah, then you will like eventually learn much more better. You will be very successful in academics as well as in your future career, whatever it is. Whatever the AI comes or whatever the AI goes, you will stay top on the world. And what should be the first year freshers do? Yeah, exactly the same thing. Just focus on building your foundation very well. Don't care about the trends or like whatever it's going on. Just try to focus more on the foundation and keep following up the trend. Like whatever it is coming, like try to be adaptable and learn the fundamentals. It's nothing like if AI comes, you should drop learning the fundamentals. Like ChatGPT can solve thousands of problems. It doesn't mean that you should not solve. To generate that, you need to be like understand these all fundamentals, right? So keep learning the foundation very well, understand it very well, have curiosity. Then yeah, then the first, second, third year, whatever the final year, you guys will do wonders. Any other questions? I think it's 3, 4. Any questions? Okay, like if you have any questions in the future, you can contact me anytime. And all the best and welcome to SC Engineering College, and like all the best for everyone. So yeah, see you in future maybe. In which subject we should be strong with? So that depends on interest. I would say mathematics is very common, and if you learn math, then math is the AI actually. Deep learning, machine learning is nothing but it's just a fancier term. Mathematics is called. So mathematics is the most important. Then subjects of your interest. For me, it's a signal processing interest. So I have studied signal processing very well. For many of them, it will be VLSI or embedded system or circuit designing or RF and antennas. So there is n number of subjects which people have different interest in. So have interest in one, multiple if you want, like, but you should have at least one interest core. You study that very well. You should understand everything. But mathematics and AI is common. Deep learning, machine learning, very common. Yeah. Thank you, Vel Gautam. Okay, then like see you guys. Like enjoy the rest of the session and rest of the 4 years. Probably I will be visiting in 2 to 3 years or like to our college. Like maybe we'll see you in person. Until then, okay. Bye, Bob. Bye to everyone.
Thank you, sir. As we come to the end of this insightful session, I would like to express our sincere gratitude to Mr. Rajesh R. for sharing his valuable knowledge, experiences, and expertise with us today. Your session on From Smart Devices to Smart Worlds, Engineering the Future through ECE, has provided us with meaningful insights into the rapidly evolving world of technology and the endless opportunities within the field of electronics and communication engineering. Your words have truly inspired and motivated our aspiring engineers. I would also like to extend our heartfelt gratitude to the management of SC Engineering College for their constant encouragement and support in organizing such valuable initiatives. Our sincere thanks to our respected faculty members, event organizers, and technical team for their dedication and efforts in making this session a success. A special note of appreciation goes to all the students who joined us today. We hope this session has offered valuable guidance as you prepare to begin your engineering journey. Before we conclude, I kindly request all participants to fill out the feedback form, which is shared in the chat. Your feedback is valuable to us and will help us improve future sessions. Thank you all for your active participation. Have a wonderful day.